Welcome to Grade 10 Mathematics Classroom. Today we are going to do a geometrical lesson, that is the 31st unit in your mathematics textbook. The lesson is angles in a circle. Right. Before moving to the lesson, I am going to introduce you a special person. See whether you can identify this person. Right. Who is this? This is a great mathematician called Euclid. So, he is named as the father of geometry. So, before starting the lesson, we have to mention about him because this is a geometrical lesson. Right. We will move on to our lesson. So, before starting the lesson, I want to tell you what you are going to learn after studying this lesson. By studying this lesson, you will be able to identify and apply the theorems related to angles in a circle. Now, before moving to the theorems, first of all, we'll identify what an arc is. You have already learnt about this, but we'll recall the memory of arcs. Right. Here, I have got a circle. In this circle, I have colored a portion. That means a part of a circle. So, I am going to name that portion. The two endpoints of the portion is A and B. Right. Now, when I consider about the portion ACB, I can name it as an arc. At the same time, we can name ADB also as an arc. So, ACB is smaller than ADB. Therefore, I can give two names. ACB is the minor arc because it is the smaller one, and ADB is the major arc because it is the much greater one. So, I have got two arcs now. ACB, that is the minor arc, and ADB, that is the major arc. Right. Now, have a look at this. Now, I have got 2 points on the circle. AB. Right. Once again, AB is the two endpoints of the minor arc. So, what I have done now? I have joined AO and OB. That means I have marked the two radius AO and OB. I can form an angle AOB when O is the center of this circle. So, we can say the angle AOB, which is formed by joining the end points of the minor arc AB, which is indicated by the thick line in the figure, to the center, is defined as the angle subtended by the minor arc AB at the center. Now, this angle is subtended by this minor arc AB and it is subtended at the center of the circle. Right. Previously, I have mentioned that we have got a major arc here as well. So, we will see. If I consider the major arc AB, here you can see the major arc AB. Now, once again, I have subtended an angle on the center of the circle, this time by the major arc AB. Right. So, we can say the reflex angle AOB, which is formed by joining the endpoints of the major arc AB, which is indicated by the thick line in the figure, to the center, is defined as the angle subtended by the major arc AB at the center. Now, previously we got an angle which is less than 180 degrees. Now, here we have got an angle which is greater than 180 degrees. So, we can call it as a reflex angle. Right. Now have a look at this one. Once again, I have got a minor arc. This time, what have I done? This time, I am not going to subtend an angle on the center. This time, I have subtended an angle on the remaining part of the circle. Right. Now, point C is on the remaining part of the circle. When I consider AB minor arc, the AB major arc is the remaining part of the circle. So, point C is on AB major arc. So, here we are talking about the angle subtended by a minor arc on the remaining part of the circle. So, we can call ACB is the angle that is subtended by the minor arc AB on the remaining part of the circle. Right. Likewise, we have got the major arc as well. So, we will see the angle subtended on the remaining part of the circle by the major arc now. So, once again I have got the major arc AB. So, this time I am going to subtend an angle on the remaining part of the circle. So, when I consider the major arc AB, the remaining part of the circle should be the minor arc AB. Right. So, I can say angle ADB in the given figure is defined as the angle that is subtended on the remaining part of the circle by the major arc AB. Right. By now, you know about the minor arc and the major arc. Then you know about the angle subtended on the center of the circle by the minor arc. Then the angle subtended on the center of the circle by the major arc. Then we have discussed about the angle subtended on the remaining part of the circle by the minor arc. Finally, we have discussed about the angle subtended on the remaining part of the circle by the major arc. Right. I think now it's clear that there are two, when we mark 2 points on the circle, we can have major arc and minor arc. So, I think the angles are also clear for you. So, we will move on. Right. Now, what can you see here? I have got a circle and I have marked 3 points on the circumference of this circle. So, I can name those points as A, B and C. And I have to mention the center of this circle is O. Right. Now, I am going to give you a small work to do. Now, we are going to identify the angles subtended at the center and the angles subtended on the remaining part of the circle. Now, I am going to give you some major arcs or minor arcs. You have to tell me the angle subtended on the center or the angle subtended on the remaining part of the circle. Right. So, I am going to do it with you. So, you have to do it before me. Okay, we will see. Right. First one. By the minor arc AB. So, we have to consider about the minor arc AB. So, can you show me the minor arc AB? We will see here. This is the minor arc AB. Isn't that so? So, we have to consider about the angle subtended at the center by this minor arc AB. So, where is it? Here. This is the angle subtended at the center by the minor arc AB, that is AOB angle, but this angle is less than 180 degrees. So, we can say the angle subtended at the center by the minor arc AB is angle AOB. Then we have to find the angle subtended on the remaining part of the circle by the minor arc AB. Right. Now, if we consider the minor arc AB, the remaining part of the circle can be considered as ACB. Right. Now, what is the angle subtended on the remaining part of the circle? Now, we can see that is ACB angle. So, we can say the angle subtended on the remaining part of the circle by the minor arc AB is angle ACB. Right. We'll move on to the other one. Right. This time we have to find about the angle subtended at the center by the minor arc BC. So, first of all, we'll identify what is the minor arc BC. Here, can you see? This is the minor arc BC. So, what is the angle subtended at the center by this minor arc? So, we'll see this is the minor arc BC. So, angle subtended at the center is BOC. So, we can say angle BOC, or else we can name the same angle as angle COB. Both are the same. So, that is angle BOC. Then we have to think about the angle subtended on the remaining part of the circle by the minor arc BC. Once again, this is minor arc BC. Therefore, the remaining part of the circle can be considered as BAC. Right. Now, what is the angle subtended on the remaining part of the circle by the minor arc BC? Here, this is the remaining part. Now, the angle subtended on the remaining part of the circle by the minor arc BC can be considered as angle BAC. Right. So, we have got the answer for that as well, that is angle BAC. Right. Then the next one. Now, they have got by the minor arc AC. Right. Now, we have to go understand, we have to identify two angles, angle subtended at the center by the minor arc AC, then the angle subtended on the remaining part of the circle by the minor arc AC. Right. Now, first of all, we will identify what the minor arc AC is. Right. Now, here this is the minor arc AC. If we consider this side, that is the major arc. Right. Now, first of all, angle subtended at the center by the minor arc AC. Right. Can you observe the angle? That is AOC. So, we can say the angle subtended at the center by the minor arc AC is angle AOC. Right. Then we have to identify the angle subtended on the remaining part of the circle by the minor arc AC. As I have mentioned before, this is minor arc AC. Therefore, the remaining part of the circle should be the part other than the minor arc. Right. Now, we can observe the angle ABC is on the remaining part of the circle. So, that is the angle subtended by the minor arc AC on the remaining part of the circle. So, we can name it as angle ABC. This time also we have to identify the angle subtended on the center of the circle and the angle subtended on the remaining part of the circle. Right. We will take one by one. First one, angle subtended at the center by the major arc AB. Right. First of all, we will identify what the major arc AB is. Right. We can observe two arcs when we consider about AB, that is APB and ARCQB. Right. Major arc should be the greater one. Therefore, this can be taken as the major arc. That means ARCQB is the major arc of this AB. Right. Now we have to think about the angle subtended at the center by this major arc AB. Right. What is that? Here, this is the angle. So, we can consider this angle as the angle subtended by the major arc AB on the center of the circle. Right. But if I name it as just angle AOB, what would happen? Previously also we got some equal angle. When I consider angle AOB, I can have the smaller one or the larger one. Therefore, we have to mention it clearly as the reflex angle AOB. Now, here the angle subtended at the center by the major arc AB is the reflex angle of AOB. Right. Then the angle subtended on the remaining part of the circle by the major arc AB. As I have mentioned here, the angle subtended on the remaining part is, now here this is the remaining part of the circle if we consider about the major arc AB. Therefore, the angle subtended on it can be seen as angle APB. So, we will mention that also. Right. Now, the next one. Then, the angle subtended at the center by the major arc BC. So, first of all, we will identify what the major arc BC is. Right. Now, we have got B here, C here. If I consider this one, it is the minor arc. We want the major arc. Therefore, major arc BC should be taken as BPARC, the arc which goes through the points P, A and R. This is the major arc BC. Right. First of all, we will consider about the angle subtended at the center of the circle by the major arc BC. So, what is that? We will see. First, we will just get the major arc. Right. Now, here we can see by the major arc BC, the angle subtended on the center is BOC. Right. Now, here first of all we have to consider about the major arc BC. So, here we have mentioned, I have mentioned the major arc BC, and now we have to think about the angle subtended at the center of the circle by this major arc. So, here we can see the angle subtended on the center of the circle by the major arc is angle BOC. But once again, when I say the angle BOC, we can consider two angles. One angle is less than 180 degrees and the other angle is a reflex angle. Now, here in this occasion, we have to consider about the angle BOC reflex angle. So, we have to mention that as well. Right. Now, we will have a look at the angle subtended on the remaining part of the circle by the major arc BC. Right. Once again, the major arc BC is here. So, the remaining part of the circle can be clearly observed. Now, the angle subtended on the remaining part of the circle can be observed as angle BQC. Next one. The angle subtended at the center by the major arc AC. So, first of all, once again we will identify what the major arc AC is. Now, we have got A here, point C here. So, what is the major arc AC? Right. Now, if I consider this part, that means this arc, it is the minor arc. Therefore, we have to consider the major arc, the larger one. Right. Now, first of all, what is the angle subtended at the center by this arc? Right. Now, this is the major arc. So, angle subtended on the center should be considered as this angle. So, that is angle AOC. Once again, when I say angle AOC, there are two angles. One is less than 180 degrees. The other one is a reflex angle. Here in this occasion also, we have to consider about the angle AOC, reflex angle. So, we have to clearly mention that. Right. Finally, the angle subtended on the remaining part of the circle by the major arc AC. Right. Now, we will understand what the major arc AC is. Now, once again, this is major arc AC. Now, what is the angle subtended on the remaining part of the circle? Now, this is the remaining part. So, the angle subtended on the remaining part of the circle by the major arc AC is angle ARC. So, we will mention that also. So, we know how to identify angles subtended by major arcs, angles subtended by minor arcs on the center of the circle and on the remaining part of the circle. So, now we have to consider about the theorem related to these angles. So, we will have a look at the theorem now. This is our first theorem for today. That is, the angle subtended by an arc at the center of a circle is twice the angle subtended by the same arc on the remaining part of the circle. I will say it once again. The angle subtended by an arc at the center of a circle is twice the angle subtended by the same arc on the remaining part of the circle. What does it mean? Now, here I have got a circle. Now, we will get an arc. Right. Now, I have got AB minor arc and I have mentioned AOB angle. By now, we know that is the angle subtended on the center of the circle by the minor arc AB. Right. This, what do they say? The angle subtended by an arc at the center of the circle. Now, first part is done. We can identify that. Then the second part we will see. Right. Now, this is the angle we have discussed previously. Now, the second part. Right. Now, we can construct an equation when we consider about the theorem. Right. In the theorem, they says the angle subtended by an arc at the center of the circle is twice of the angle subtended by the same arc on the remaining part of the circle. Right. Now, we know the angle subtended by an arc on the center of the circle is AOB. Right. Now, what is the angle subtended by the same arc on the remaining part of the circle? Yes, that is angle ACB. Right. According to the theorem, we can say angle AOB is equals to twice of angle ACB. Right. I will say it once again. Angle AOB is equals to twice of the angle ACB. Right. In this occasion, we have considered about the minor arc AB. Next, we will consider about the major arc AB. We will see. Right. This time, I am considering about the major arc AB. Right. Now, what is the angle subtended on the center of the circle by the major arc AB? That is AOB reflex angle. Right. Now, this time the remaining part of the circle can be considered as the AB minor arc. Now, we are going to talk about the angle subtended by the same arc on the remaining part of the circle. So, I have marked point C on the remaining part of the circle. So, angle ACB is the angle subtended by the same arc on the remaining part of the circle. Right. once again, according to the theorem, I can say angle AOB reflex angle is equals to twice of the angle ACB. I'll say it once again. Angle AOB reflex angle is equals to twice of angle ACB. Now we know the theorem. Now it's easy for us to do some calculations using this theorem. Right. I hope you are maintaining a theorem book. It's better if you can maintain a theorem book. That means you can write all the theorems you come across in a separate book. Then it will be easy for you to go through the theorems when your examination is close by. Right. Now, don't forget to mention this theorem also in your theorems book. Right. Now, we are going to do some calculations using the theorem we have learnt. Right. Now, my question. Find the magnitude of the angle denoted by x. So, where is x? We will see. Right. Now, here I have got a circle of center O. And I have marked 3 points on the circle. Those are point A, point B and point C. Alright. Now we have to find x. By looking at this, I can say x is the angle subtended on the center of the circle by the minor arc AB. At the same time, I can observe point C is on the remaining part of the circle. Therefore, angle ACB is the angle subtended by the same arc, that means same minor arc AB on the remaining part of the circle. Right. Now, to this question, we can consider about the theorem we have just learned. Right. What do they say in the theorem? They says angle subtended at the center of the circle by an arc is equals to twice of the magnitude of the angle subtended by the same arc on the remaining part of the circle. Right. That means angle AOB should be equals to twice of angle ACB. Right. Here we know angle ACB is equals to 50 degrees. Now, x should be twice of it. So, we can say the magnitude of x is equals to 100 degrees. Right. We'll move on to another one. Right. Here also we have to find the magnitude of x. Right. Once again, we can see a circle of center O and there are 3 points on the circle, point A, B and C. Right. By looking at this picture, once again we can observe angle AOB is the angle subtended by the minor arc AB at the center of the circle. And we can observe angle ACB is the angle subtended by the same minor arc AB on the remaining part of the circle. Right. Once again, we can relate this to the theorem we have learned previously. Therefore, we can say the magnitude of angle AOB is twice of the magnitude of the angle ACB. That means to get x, we have to divide 108 by 2, that is 54 degrees. Right. We'll move on to another one. Now have a look at this one. Once again, there's a circle with center O and we have marked 3 points on the circumference of the circle. Those are A, B, C. Right. Now we can see x, that is the angle subtended by the minor arc AB at the center of the circle. Now we'll move on to another question. Right, have a look at this one. Right, once again I have got a circle with center O and I have marked 3 points on the circle. Those are A, B and C. Right, once again I have to find the magnitude of x. So we can see x is the angle subtended by the minor arc AB at the center of the circle. And at the same time we can observe point C is on the remaining part of the circle. Therefore, point C is also subtended by the same minor arc AB. So, we can say angle ACB is the angle subtended by the same minor arc AB on the remaining part of the circle. Once again, we can relate this question to the theorem we have learned right now. So, once again, we can say angle AOB is twice of angle ACB. So, here therefore, x equals twice of 62. Therefore, we can find the value of x by multiplying 62 by 2. Therefore, the answer is 124 degrees. Right. We'll move on to another one. Right. Here what can you see? Once again there's a circle of center O and once again there are 3 points on the circumference of the circle. Those are A, B and C. Here we can see angle AOB is the angle subtended by the minor arc AB at the center of the circle. And we can observe angle ACB is an angle subtended by the same minor arc at the remaining part of the circle. So, once again we can construct an equation when we consider about the theorem we have learnt right now. So, we can say angle AOB is twice of angle ACB. That means ACB is x. So, twice of x is 2x. So, we can construct a simple equation as 2x is equals to 96 degrees. Therefore, to find the value of x, we have to divide 96 by 2. Then we can get the answer as 48 degrees. Right. We'll move on to another question. This time also we have got a circle with center O and we have marked 3 points on the circumference of the circle. Those are point A, B and C. Right. Here in this occasion we can see x is the angle subtended by the major arc AB at the center of the circle. And at the same time we can observe ACB is the angle which is subtended by the same major arc at the remaining part of the circle. So, once again we can relate this with the theorem we have just learned. So, we can construct a simple equation as x is equals to twice of angle ACB. That means x equals to twice of 115 degrees. So, we can get the value of x by multiplying 115 by 2. Therefore, x is equals to 230 degrees. Right. The next question. Here also we have got a circle and we can observe some angles. Here the magnitude is x they have given, here it is 248 degrees. So, once again we have to find the value of x. So, we can observe that angle AOB reflex angle is the angle subtended by the major arc AB at the center of the circle. Therefore, we can observe another thing, that is angle ACB is the angle subtended by the same major arc AB at the remaining part of the circle. Therefore, we can construct a simple equation that angle AOB reflex angle is twice of angle ACB. That means twice of x. That means we can say 2x is equals to 248 degrees. So, when we want to find the value of x, we have to divide 248 by 2. Then we can obtain the value of x equals to 124 degrees. Right. Now, we have completed some questions related to the theorem we have learnt right now. Right. Now, we are going to talk about another theorem. Before that, see whether you can observe these things. Once again, I have got a circle. Now, here I have marked up an angle. This is, if I consider the minor arc AB, I can say AOB is the angle subtended by the minor arc AB at the center of the circle. Right. If I get this angle as 100 degrees, what can you say about the angle subtended at the remaining part of the circle by the same arc? What can you say about the magnitude of that angle? Right. According to the theorem we have learned, it should be the magnitude of the angle subtended by the same arc at the remaining part of the circle should be half of the angle subtended by the arc at the center of the circle. Therefore, this should be half of 100 degrees. That means it is 50 degrees. Right. Now, I am going to consider about another angle. Once again, this is also subtended by the same minor arc AB. Once again, at the remaining part of the circle. Now, here I have got D in another point on the circle, that means remaining part of the circle. Right. Once again, that is also should be 50 degrees. Why? Once again, it is also related to the theorem we have just learned. Here they have used the same minor arc. So, these two angles are subtended by the same minor arc and the remaining part of the circle. Right. Now, I have got another point. This is E. Now, what can you say about the magnitude of this? Yes, that is also equals to 50 degrees. Why? When we consider about these two angles AOB and AEB, once again we can relate it to the theorem we have learnt. Right. We will take another one, angle AFB. What can we say about the magnitude? Yes, once again that is equals to 50 degrees. Then what about this? This is angle AGB. Yes, once again that is equals to 50 degrees. Right. Now, I have got several angles on the remaining part of the circle which is subtended by the same minor arc. Right. Now, I am going to forget about the angle subtended on the center of the circle. Right. Now, if I join point A and B, what can you say about this colored portion? We can consider it as a segment. Isn't that so? So, here I can see all these angles are subtended on the same segment. Right? And I can observe the magnitude of each and every angle is the same. Right. Now, I am going for a theorem. we can construct a theorem like this. The angles in the same segment of a circle are equal. Previously, we have noted that we had all the angles on the same segment. Therefore, all the angles were equal in magnitude. Therefore, we can say the angles in the same segment of a circle are equal in magnitude. Right. Now, this is the second theorem we have learned for today. Once again, you can write this down in your theorems book. Right. Now, I have got a circle and I have got an angle ACB, that is an angle subtended on the circumference of the circle. Using the same minor arc AB, I am going to subtend another angle on the remaining part of the circle, that is angle ADB. Once again, I am going to subtend another angle on the remaining part of the circle by the minor arc AB. Right. Here I can say the magnitude of angle ACB is equals to the magnitude of angle ADB, that is also equals to the magnitude of the angle AEB. We can say this using theorem we have just learned, because all these three angles are subtended on the same segment. Now, all these angles are on the same segments. Therefore, the magnitude of all three angles should be equal. Right. Once again, we will do some questions related to this theorem. Therefore, we can see whether we can use the theorem correctly or not. So, we will move on to some questions. Right. This is my first question. Right. Here I have got a circle and there are 4 points on the circle A, B, C and D. And they have given that the magnitude of angle ACB is 49 degrees and they want us to find the magnitude of the angle ADB, which is mentioned as X. Right. Here we can observe that angle ACB and angle ADB are on the same segment of the circle. Therefore, we can say the magnitude of angle ACB is equals to the magnitude of the angle ADB, that is X. Therefore, the value of X can be taken as 49 degrees. Right. One more question related to the same theorem. Right. Here also we have got a circle. We have marked 4 points on the circle A, B, C and D. And we can observe magnitude of the angle DAC is 35 degrees and the magnitude of the angle DBC is mentioned as X. So, we have to find the magnitude of X now. Then also we can observe angle DAC and angle DBC are on the same segment. Therefore, according to the theorem we have learned, we know that the magnitude of both angles should be the same. It should be the equal. We can get the magnitude of X as 35 degrees. Right. Now, that is about the second theorem we have learned. Right. Using the knowledge of the first 2 theorems, check whether you can understand this one. Now, here I have got a circle. The center of the circle is O and I have marked a minor arc AB, and here we have marked an angle of AOB, which is the angle subtended on the center of the circle by the minor arc AB. Right. Once again, if it is equals to 100 degrees, here I have got the angle ACB, that is the angle subtended by the same arc on the remaining part of the circle. So, it should be half of the magnitude of the previous angle, therefore, that is 50 degrees. I will take another set. Now, this time, angle AOB is 140 degrees. If I draw another angle on the remaining part of the circle as the angle subtended by the same minor arc, what would be the value of it? We will see. Yes, that is 70 degrees. I will get another set. This time the magnitude of AOB is 160 degrees. Once again, I am going to mention an angle which is subtended by the same arc AB on the remaining part of the circle. So, the magnitude should be half of 160 degrees. So, that is 80 degrees. Right. Now, I am going to change the angle subtended on the center once again. Right. This time, AOB is equals to 180 degrees. Right. If I says angle AOB is equals to 180 degrees, what comes to your mind? Yes. So, AOB should be a straight line segment now. Now, if we can draw a straight line segment through a circle and which is going through the center O, what can you say about that? That is the diameter of the circle, isn't that so? AO is the radius, OB is also a radius. So, if the angle is 180 degrees, of course, AOB should be the diameter of this circle. Right. Now, what can you say about the angle subtended by the same arc AB at the remaining part of the circle? Now, here I have got ACB, it should be half of the angle AOB. So, that is 180 degrees divided by 2, that is 90 degrees. Here I have considered about this arc AB. This time when we consider about the diameter of AB, we can't have a major arc or a minor arc. Why? Both arcs are equal in length. So, if I consider this arc, this is the angle subtended on the remaining part of the circle. So, you can observe the magnitude of it is 90 degrees. Right. Therefore, we can construct another theorem. That is, an angle in a semicircle is a right angle. Angle in a semicircle is a right angle. That is the third theorem we have to go through in grade 10. Right. Using this theorem, right, here I can mention the circle and AB is the diameter, therefore, ACB can be considered as angle in a semicircle. Therefore, the magnitude of ACB angle should be 90 degrees. So, I can mention another angle. So, when I consider about the angle ADB, that is also an angle in a semicircle. Therefore, the magnitude of ADB angle is also equals to 90 degrees. Right. Now, we will go through some questions related to this theorem. Find the magnitude of the angle denoted by the English letter. Now, here in first question, the English letter we have got is x. Right, we have to find the magnitude of x. According to the theorem we have learnt right now, we know that ACB is an angle subtended on right. Now, we know that the magnitude of the angles in a semicircle is equals to 90 degrees. Right. Now we will move on to some questions related to this theorem. Right. My first question. Find the magnitude of the angle denoted by the English letter. And they have said that AB is a diameter. Right. We can see 3 points on the circle A, B and C. The angle ABC is denoted as X and angle CAB is equals to 42 degrees. Right. Here we have to find the magnitude of X. Using the theorem we have learnt right now, we can say angle ACB is an angle on a semicircle because AB is a diameter in this circle. So, we know that the magnitude of the angle in a semicircle is 90 degrees. Therefore, angle ACB is equals to 90 degrees. Right. Now, we know the sum of these 3 angles should be equals to 180 degrees. The reason is the sum of the interior angles of a triangle is equals to 180 degrees. Therefore, we can say 42 degrees plus 90 degrees plus x is equals to 180 degrees. Since ACB is 90 degrees, we can say x plus 42 degrees is equals to 90 degrees. So, now it is a simple equation. We can solve it by taking x in one side and taking all the other values to the other side. So, I can subtract 42 from both sides. So, x plus 42 minus 42, that becomes x equals 90 minus 42. So, the value of x can be taken as 48 degrees. Right. Now, this is my second question. Find the magnitude of the angle denoted by the English letter. This time, we have got 2 angles in English letters. Angle ACAB is x degrees. Angle ABC is 2x degrees. Right. Once again, AB is a diameter of this circle. Therefore, I can consider angle ACB as an angle on the semicircle. So, the magnitude of angle ACB can be taken as 90 degrees according to the theorem we have learned. Right. Now, angle ACB is a right angle. So, it is equals to 90 degrees. Once again, we know the sum of the interior angles of a triangle is 180 degrees. So, when we get the sum of these 3 angles, it should be equals to 180 degrees. Since angle ACB is equals to 90 degrees, I can say x plus 2x is equals to 90 degrees. Right. Once again, this is a simple equation. So, I can simplify this and get the value of x. So, x plus 2x becomes 3x. 3x is equals to 90 degrees. So, to get the value of x, I can divide both sides by 3. Therefore, I can get the value of x as 30 degrees. We will move on to another question. Once again, we have to find the magnitude of the angle denoted by an English letter. Right. Once again, AB is a diameter. Since AB is a diameter, angle ACB is an angle on the semicircle. So, we know that the magnitude of the angle in a semicircle is 90 degrees. At the same time, they have mentioned AC is equals to CB. Therefore, we can say ABC is an isosceles triangle. In isosceles triangles, we know the angles, there are 2 equal angles. If the angle CAB is x degrees, we can say angle ABC is also x degrees because both the angles are equal in magnitude as triangle ABC is an isosceles triangle. Right. Once again, we know the sum of the interior angles of a triangle is equals to 180 degrees. So, when we add these three angles together, the sum should be equals 180 degrees. Since angle ACB is 90 degrees, I can say angle CAB plus angle ABC is equals to 90 degrees. Therefore, x plus x equals 90 degrees. So, x plus x can be taken as 2x equals 90 degrees. We can find the value of x by dividing both sides by 2. Therefore, magnitude of x is equals to 45 degrees. Right. We will move on to another question. Here we have to find the value of x and y both. Right. So, we will take one by one. First of all, I am going to find the value of x. Here they have mentioned BC and AB are parallel lines. Since those two are parallel lines, what can you say about the angle DCA and angle CAB? Those are alternative angles, isn't that so? So, since those are alternate angles, I can say those two angles are equal in magnitude. So, the magnitude of x can be taken as 46 degrees. Right. Now, we can find the value of y. Can you observe that angle DCA and angle ABD are on the same segment. Therefore, we know that the angles on the same segment are equal. Therefore, we can say the value of y is equals to 46 degrees. Right. Then the next one. Here we have to find the value of a, b, x and y. So, we will take one by one. First of all, I am going to find the value of x. Here I have got the triangle ABC. Since it is an isosceles triangle, we know that angle ACB should be equals to angle ABC. So, we can take angle ABC also as equals to x. Right. Now, at the same time, we know that the sum of the interior angles of a triangle is equals to 180 degrees. Therefore, 32 degrees plus x is equals to 180 degrees. X plus x can be taken as 2x. So, 2x plus 32 degrees equals 180 degrees. So, I am going to subtract 32 from both sides. Therefore, 2x is equals to 148 degrees. To find the value of x, I can divide both sides by 2. When I divide 148 by 2, I can get 74 degrees as the magnitude of x. Right. Now, we know the value of x. Then we will find the value of y. We know that x and y are two angles on the same segment. Therefore, the magnitude of x should be equals to the magnitude of y. Therefore, the magnitude of y is also equals to 74 degrees. Right. Then we will move on to another angle, that is A. Right. Here we can observe that triangle ABD is an isosceles triangle. Therefore, angle BAD should be equals to the angle ADB. Therefore, A plus 32 degrees should be equals to 74 degrees. So, once again we have formed a simple equation. So, by simplifying this, we can get the value of A. So, I am going to subtract 32 from both sides. Therefore, I can get the value of A as 74 minus 32, that is 42 degrees. Right. Now, we have got the value of x, y and A. Finally, we have to get the value of B. Once again, can you observe that angle A and angle B are on the same segment? Right, now we have got the values of x, y and a. Now have you observed that angle A and angle B are on the same segment? Right, therefore, the magnitude of angle A should be equals to the magnitude of angle B. Therefore, we can get the magnitude of angle B as 42 degrees. Right, now that's the end of the lesson, but we have to talk much more about the practical part of this lesson. So, we will do it in the next session. So, before that, we will summarize the things that we have learned today. First of all, we have learnt about the theorem, which is the angle subtended on the center of the circle by an arc is twice of the angle subtended on the circumference of the circle by the same arc. Then we have talked about the angles on the same segment, and we have learned that the angles on the same segment are equal. Finally, we have discussed on the angles on a semicircle. So, we says the magnitude of the angle in a semicircle is 90 degrees. So, that is what we have learned today. If you have missed the lesson or if you want to go through the lesson once more, you can watch this lesson through the YouTube channel, Channel NIE. So, that's it for today. See you in another lesson. Take care.